is our A2 tractor with a DC power supply, 635 amps. Actually, it'll run 60% duty cycle up to 800 amps. We've got this with the PEI controller, which is an analog controller. The reason we're showing this here today is because it can be used with a junction box to connect to most competitive power supplies. So that's why we wanted to show this off today with just the analog control. What we're using here for the wire is 1/8 inch full arc 81, which is an EM 12K type wire with OK Flux 350, which is an active flux. We consider it probably our most general purpose active flux. So being an active flux is capable of running over some rust and mill scale. So it's more tolerant to plate conditions. We're going to go ahead and run it here. I've got the flux engaged. I've got my settings all ready. So I'll open up the flux hopper, get the flux flowing out of the tube. The wire's already been set up with the correct electrical stick out. So once you've got everything set up, the flux is there, the wire's prepped, just hit the green button. Let it well. Now we're running a pretty wide, flat bead like this one, just for the purposes of demonstration. We accomplish that by running a fairly high voltage, 32.5 volts, at about 535, 540 amps. So we're only running 12 inches a minute. This is not necessarily something you see commonly in actual fabrication, but this shows a really nice bead and the capabilities of the process. We'll go ahead and begin shutting it off so we can look at the actual well. And when we want to shut it off, what we do is hit the red button. We'll disengage the clutch, slide the machine back. Now it's very hot right now. We can start to remove some of this flux, this excess flux. And normally, we would have a flux recovery system that had a vacuum that would suck the flux back up and put it back in through the top. And that's why this grate's here, to keep any larger particles from getting through. But for this demo, we didn't want the noise of the vacuum system. Start to get an idea of how hot this is. There's quite a lot of heat being put into the plate in terms of kilojoules per inch, which is a function of volts, amps, and travel speed. I'm going to let it cool down a little bit more. And as it cools down, that flux will, that slag will release pretty easily from the well. You shouldn't have to chip or anything like that. That's still quite hot, so as it cools, it'll release for us. You see how wide we got that bead with that high voltage. Some of these other beads like this one will run at a slightly lower amperage, but a much lower voltage. Higher voltage causes the arc to spread out. So you get a wider bead with less penetration.